What's going on, everybody? Got another video here for you. This one is improper integrals. All right, so I've got another lecture video on improper integrals. It's for calculus, not applied calculus. The examples in that video are going to be a little different than these, so you can, well, they're going to be different problems, so you can go check that video out if you need to see more examples. All right, so let's get started. So if we have an integral where we going from a to infinity or negative infinity to a or negative infinity to positive infinity, well, let's just look at the first one. So we've got the integral of f of x dx from a to infinity. So what we're going to do is we're going to take the limit as t goes to infinity of the integral a to t of f of x dt. So we can't really plug infinity in for a variable. So what we're doing is we're replacing this infinity here with the t, and then we're taking the limit as t approaches infinity or as t goes to infinity. And same thing here. If we've got the negative infinity here, we're replacing that negative infinity with a t, and then we take the limit as t goes to negative infinity. And then if you're going from negative infinity to infinity, well, we can split that up, negative infinity to a plus a to infinity, and then we would work it with one of these up here. Okay, we would do this one like this and this one like this. So if both bounds on your integral are infinity and negative infinity, then you got to split it at a number and break it up into two integrals. Okay, we're going to do examples of all of them, so let's go ahead and get started. All right, so here we have the integral of e to the x dx from negative infinity to 0, if it exists. Oh, and one thing that I want to mention here, if, let's see, if the limit exists, then the integral is convergent. And if the limit does not exist, then the integral is divergent. Okay, so they may ask you in the directions to determine if the integral is convergent or divergent. And if it's convergent, give the value. Okay, so that's what it means. If you can take the limit exists, convergent. If it does not exist, if the limit does not exist, then it's divergent. All right, so let's go ahead and do this one. So we've got the integral from negative infinity to 0, e to the x dx is equal to the limit as t goes to negative infinity, integral t to 0, e to the x dx. All right, so we replace the negative infinity with the t, and then we take the limit as t goes to negative infinity. All right, so we integrate e to the x. So this is going to be the limit as t goes to negative infinity of e to the x from t to 0. And that is equal to the limit as t goes to negative infinity of e to the 0 minus e to the t. And we've got to determine what this is. All right. So this is equal to 1, e to the 0 is 1, minus, now let's figure out what this is. Okay, so I'm going to come down here and let's just talk through this. All right, so we've got e to the t, and t is going to negative infinity. All right, so let's just look at that. If we take e and just put negative infinity in there, okay, so basically it's e raised to a negative and then a big number, okay, negative 1 trillion, negative you know, just the numbers get larger and larger. Now, remember, if you have, say, e to the negative 2, that's the same thing as 1 over e to the 2. Remember, you can move this down and it changes the sign of the exponent. If you move something across the fraction bar, it changes the sign of the exponent. So this would be like 1 over e to the positive infinity, or e to a really, really big number. So what I'm getting at is this denominator here is getting really, really big, and that is staying at 1. The numerator is staying at 1. But the denominator is getting larger and larger and larger. So what happens to a fraction when the numerator, it's just some number, but the denominator is getting larger and larger? Well, the whole fraction goes to 0. So this would be minus 0, and that equals 1. Okay? All right, let's look at the next one. It says, a rocket is launched vertically with a velocity v in miles per hour as a function of time t in hours. Of v equals 30,000 over t plus 1. Show that the rocket will eventually be as far from the Earth as may be required. The distance from Earth is s equals this. So we need to integrate this. All right. So let's see what we get. So, you know, it's a word problem, but basically it's an example where the upper bound's infinity. Here we did the lower bound is in negative infinity. All right, so let's see what we get. So we get 0 to infinity, 30,000 over t plus 1. And I tell you what, you know what I'm going to do? I know the problem says t, but I'm going to change this to an x. Okay? So, and the reason I'm doing that is because we're using t. Well, no, I tell you what, let's do this. Let's do this. Let's keep it a t. Okay? Let's keep it t. All right. So what we'll do here is this is equal to the limit. Now, I just changed it back to t. So what we have here is when we did this, what did we do? We did as t goes to infinity. Okay, our variable, the variable of our function was x, but here we used t. Okay, so normally we would replace this with a t and say t goes to infinity, but since t is a variable in our function, let's just use a different letter. Let's use b. Okay, b goes to infinity, integral 0 to b of 30,000 over t plus 1 dt. All right, so now we have to integrate this. Okay, so what's the integral of that? Well, let's look. Let's come down here, and I'll say this on these problems, it might be best for you to just go off to the side and integrate this without any limits. Okay, so this 30,000 over t plus 1, let's bring the 30,000 out, and that's 1 over t plus 1 dt. All right, you should know how to integrate this thing. Okay, this is what? Well, let's talk about it, and then I'll do the u substitution with it. But look at this denominator. What's the derivative of the denominator? Well, the derivative of the denominator is 1. And what happens if the derivative of the denominator is in the numerator? Well, that equals what? That's natural log of t plus 1, right? And see, you can see that. If we let u equal t plus 1, then du is equal to dt. So this is going to be the integral 1 over, in the place of t plus 1, we're going to put u. In the place of dt, we're going to put du. And so we replace the dt with du, so we would have du here, and you can see that that's natural log u. Okay, this is the form of that. And so then we would have natural log, and then we replace the u with t plus 1. But, you know, by this point in your calculus career, you should be able to see that, say, well, the derivative of the denominator is in the numerator, so that's natural log. Okay? All right. So let's erase this. All right. So here we have, well, let's write it down here. So we have the limit as b goes to infinity of 30,000 times natural log of t plus 1, and that's going from 0 to, I'll put the limit. All right. So we're taking the limit of this thing. And so this would be the limit as b goes to infinity of 30,000 times, and that's natural log of b plus 1. Well, and I know it's absolute value, but we don't need to put absolute value because we know b is positive, and a positive number plus 1 is positive, minus natural log of, and what's that, 0 plus 1. All right, so let's look at this. Well, the natural log of 1 is 0. And then let's look at this one. B is getting larger and larger, right? B is going to infinity. All right. So if we're taking the natural log, take the natural log of 100, 1,000, 10,000, 100,000, million, billion, trillion, and keep going. Well, the larger the number that we're taking the natural log of, the larger natural log's getting. So as B gets larger and larger, this whole thing here is getting larger and larger. So we would say this is going to infinity. All right. And this actually diverges. All right. So let's take a look at this problem. It says evaluate dx over x squared plus 4x plus 5 from negative infinity to infinity if it exists. All right. So for this one, we've got negative infinity to infinity dx over x squared plus 4x plus 5. And so that's going to be negative infinity, so we're going to have to split it. That's this one. All right, and we will split it at 0. Dx over x squared plus 4x plus 5 plus 0 to infinity dx over x squared plus 4x plus 5. All right. So now we're going to have the limit as t goes to negative infinity. Okay. Well, I tell you what, let's do this. Let's just stop right there. So what we have to do now is we have to integrate this. Okay. Work it like it's two separate problems. Okay. Do this one, and then add the results together. That's all you got to do. So let's take this one first. So I've got 0 to infinity dx over x squared plus 4x plus 5 is equal to the limit as t goes to infinity. We're doing this one, and that's 0 to t dx over x squared plus 4x. Now let's look at this. We've got to integrate this thing. Doesn't really look much like anything we know. We could use partial fractions. Okay, partial fraction decomposition. But let's look at this. Let's try this. Let's just see what happens if we do this. Let's group those together, and let's complete the square on this bottom one. So if I take the 4 and half it, that gives me 2. 2 squared is 4, so I add 4. And so that means I have to come out here and subtract 4. So this is the limit as t goes to infinity, 0 to t of dx over x plus 2 squared plus 1. All right. So at first, when you look at it, it might look like, well, that doesn't really help me much. But look at it a little closer. What if we do this? What if we integrate dx over x squared plus 1? What's the antiderivative of that? Well, that's what? That's inverse tangent x, right? Well, you can see this is in the same form as this. Instead of the x being squared, the x plus 2 is squared. So this would be the limit as t goes to infinity of what? Of inverse tan x plus 2, right? See, we've got x plus 2 instead of x. And that's going to go from 0 to t. And so this is going to give us the limit as t goes to infinity of, and that is going to be inverse tan of t plus 2 minus inverse tan of 0 plus 2. Okay. All right, so let's look at this. So if we integrate this, okay, so t is going to infinity. All right, t's getting really, really big. Okay, so that means we're taking the inverse tangent of a number that's getting larger and larger and larger and larger. Well, I've already got this drawn down here. This is the graph of inverse tangent. This is your t-axis. So you can see as the values of t get larger and larger, what is inverse tangent getting closer and closer to? It's getting closer and closer to pi over 2. And so this is pi over 2. So this is going to be pi over 2 minus, and then this is just inverse tan 2. So we'll leave it at that. All right. So that's this one. Now let's do this one. So here we have the integral, and that's negative infinity to 0 dx over x squared plus 4x plus 5, which is equal to the limit as t goes to negative infinity, t to 0, dx over x squared plus 4x plus 5. All right, now let's look at this. So this is going to be the same thing as what we did up here. Notice when we integrated this, what did we get? We got this. Well, we're going to get the same thing when we integrate that. The only thing that's going to be different is going to be the limit as t goes to negative infinity, and this is going to be t, and this is going to be 0. So this is going to be the limit as t goes to negative infinity, integral, and that's going to be t to 0, and that's going to be inverse tan x plus 2. We already integrated it once. Okay, so now this is going to give us, let's see, the limit as t goes to negative infinity of, let's see, we've got inverse tan of 0 plus 2 minus the inverse tan of t plus 2. All right. So this is going to give us inverse tan of 2 minus, now what is this? T is going to negative infinity. I mean, yeah, you got the plus 2 there, but that plus 2 isn't going to have much bearing on infinity. So we're going to negative infinity, and you can see inverse tangent is going to negative pi over 2. So that's negative pi over 2. So this is inverse tan of 2 plus pi over 2. And so remember what we said. We take this answer and this answer, and we have to add them together. So the limit, So the integral negative infinity to infinity of dx over x squared plus 4x plus 5 is equal to this value, which is inverse tan of 2 plus pi over 2 plus this value, pi over 2 minus inverse tan of 2. And you can see the inverse tan 2's go out, and pi over 2 plus pi over 2 is pi. And there's your answer. All right. So that was a pretty good problem. You know, and like I said, if you have to split them up, just evaluate them individually. Okay. All right. So now let's take a look at this one. If f of x is continuous for x between a and b, but notice it's not continuous at a, okay, then the integral a to b f of x dx is equal to the limit as t approaches a from the right of the integral t to b f of x dx. And then if it's discontinuous at b, then it's the limit as t goes to b from the left, the integral a to t f of x dx. And then if we're going, now look, you see how this is going from the right, from the left? Don't try to memorize that. When we go to work the problems, I'm going to show you how you can determine if it's from the right or the left without having to memorize that. All right, and then if f of x is continuous on a and b, and notice it's continuous at a and at b, except at c, where c is some number in between the two, then what you'll do is you'll just split it at that c value. Okay, and then you'll apply these. Okay. All right, so let's do an example. Find the first quadrant area bounded by y equals 1 over square root of x at x equal 4. All right, so I mean, this right here is just finding the area. Remember when you did area between curves? Okay, so if we graph this thing, okay, so 1 over the square root of x is going to look like this. Okay, now how did I know it looked like that? Well, I can graph it on some software, something like that. Okay, and you might be thinking, well, what if I don't know how to graph it, and I'm taking a test and I don't have a book, I don't have software? Okay, well, that's fine. Let me draw this. This is x equal 4. And so we're looking for this area right here. Okay. All right. So you might be thinking, you know, how am I going to graph it? Well, do you remember when you graphed critical numbers, increasing, decreasing, relative max, min, concavity, inflection points? You found asymptotes, all that good stuff. There you go. That's how you would have to do it. Now, would your teacher give you a question like this on the test that was difficult? Because this is a pretty tough one it would take a little time to graph. Maybe not much time, but a little time. They might not. I don't know. I probably wouldn't. But anyway, let's integrate it. So for the area, we know that is the integral 0 to 4 of 1 over square root of x dx. All right. Now, notice this function here is undefined at 0. Okay? Well, it's undefined at 0. So what I would need to do here is I would need to do the limit as, well, let's use t goes to 0. All right, now let's think about this. That's going to be t to 4, and this 1 over square root of x, I'm going to write that as x to the negative 1/2 dx. Okay, so where it's undefined, that's what we're replacing with 0. Now, do I need to come in from the left or the right? Now, let me show you. Yeah, it says it up here, but forget about that. Don't try to memorize that. Look at this. Where are we at? We are from 0 to 4, right? That's what we're going through, from 0 to 4. All right. So, look, we're inside this interval here, okay? Now, how can we get to 0? We've got to come this way, right? We're not going to come from outside of 0 to 4. We're going to come from the inside here, okay? So we're going to be approaching 0 from which side? From the right side, okay? And you can see, where is it? You see there? You see how it was the bottom? It was the bottom one. We're coming from the right, okay? All right. So now this is going to be the limit as t goes to 0 from the right. All right, so what do? We got x, add 1 to the exponent, so that's 1/2, multiply by the reciprocal of your new exponent, and that's going from t to 4. And so this is the limit as t goes to 0 from the right of 2 times, and this x to the 1/2, that's the same thing as square root of x, so that's square root of 4 minus square root of t. All right. And so to take the limit, well, we can just take the 0 and plug it in for t. And so this is going to be 2 square root of 4 minus 2 times square root of 4 minus square root of 0, which that is just 4. And there's your answer, because square root of 4, I don't know what's going on with my computer. It's like stuff's trying to open on it. I don't know. Anyway, I don't know if I'm accidentally hitting stuff or not. But anyway, square root of 4 is 2. 2 times 2 is 4. And so there's your answer. Okay. So, you know, it's really kind of similar to what we did on the previous ones. You just gotta be able to split it up. All right. So let's look at the next problem. All right. So here I have the integral 0 to 1 dx over x minus 1 to the 1/3. All right, and notice this one is undefined at 1, the function is. And so here we've got the limit as t goes to 1, the integral 0 to t, and I'm going to go ahead, I guess I'll go ahead and write this as x minus 1 to the negative 1/3 dx. Go ahead and move it up. And now look at this, 0 to 1, it's undefined at 1. So if you look at it, 0 to 1, we've got to be inside the interval to get to 1. And so we're coming in from what side? We're coming in from the left-hand side. So that approaches 1 from the left. All right. All right, so, you know, like I said before in the earlier problems, if you have something that might be a little more complicated to integrate, then go off to the side, integrate it, and then just write your answer down. And then that way you don't have to keep writing this limit every time. So if we just look at this, x minus 1 to the negative 1/3 dx, well, how would you integrate that? Well, you let u equal x minus 1, du is dx, and so that's going to be the integral u to the negative 1/3 du, which is equal to u to the, what is that, 2/3, and then that would be 3/2 plus c, so that would be 3/2 x minus 1 to the 2/3 plus c. All right. So we know this would be the limit as t goes to 1 from the left, and that is going to be 3/2 times x minus 1 to the 2/3, and that is from 0 to t. Okay, so all I did is I replaced this, I integrated it, and replaced it with that. We don't need the plus c when we have bounds on our integral. Okay, so that's all I did. I came down here, I integrated this, and put my answer up there. And I've got to take the limit of all that. All right, so let's evaluate that limit. All right, so this is going to be the limit as t goes to 1 from the left, and that's going to be 3/2 times, so let's plug the t in, so that's t minus 1 to the 2/3 minus, what is that, 0 minus 1? Yep, 0 minus 1 to the 2/3. All right. And so now this is going to be, let's see. Well, look at this. What happens when I plug 1 in? That's 0, right? So we know that term there is going out. It's going to 0. All right. So basically what we're left with is we're basically left with 3/2 times, we got the minus here, and that's going to be -1 to the 2/3. Okay, see, 0 minus 1 is -1. And so let's see, remember, -1 raised to the 2/3, that is equal to the cube root of -1, and you could write that squared like that. So that's -1. -1 squared is +1. So this right here is +1, and so, and I got the negative, so that's going to be -3/2, and there's my answer. I don't know why my computer is writing slow. I don't know, stuff's flashing. I don't know what's going on. All right. Well, we got one more problem to work, so we'll see. We'll see what happens. There we go. All right, so this is the last one. My computer's going crazy. It's been acting up lately. All right, so let's look at this one. We've got 0 to 2 dx x minus 1. Ooh. All right. I had to restart my OneNote. I don't know what's going on. I might have too much stuff in my OneNote. I've got a ton of stuff written up where I've done these videos. So let's see what we got here. This is going to be x minus 1 squared. All right, so notice this thing, we're going from 0 to 2. It's not, the function's not undefined at 0, and it's not undefined at 2. But it is undefined at 1, which is between 0 and 2. So what we'll do is we'll break this up, 0 to 1 dx over x minus 1 squared plus 1 to 2 dx over x minus 1 squared. All right, so this is kind of like the last one where, okay, we're gonna do each one of them separately. Okay, so I don't know, let's do this one over here, the one on the right. So I've got 1 to 2 dx over x minus 1 squared. That's equal to the limit as t goes to 1, and that's going to be t to 2 dx over x minus 1 squared. All right, now look at this. We've got 1 to 2, right? So we're going to be coming in from what side? The right side, approaching 1 from the right. And so once again, let's come down here and evaluate that integral. So that's going to be 1 over x minus 1 squared dx, which is the integral x minus 1 to the negative 2 dx. And so we're going to let u, equal x minus 1, du is dx. So this is going to be u to the negative 2 du, which is equal to u to the negative 1 multiplied by the reciprocal of your new exponent. And so that's going to be negative 1 over the u we're going to bring to the denominator, and that would be x minus 1. All right. So this is equal to the limit as t goes to 1 from the right, and we integrated that. That's going to be negative 1 over x minus 1 from t to 2. Okay, so all I did is I replaced that integral with what I got after I integrated it. Okay, all right. Now, this is equal to the limit as t goes to 1 from the right. All right, so that's going to be negative 1 over 2 minus 1 minus a negative 1 over t minus 1. Okay. All right, so this part right here, well, that's just negative 1. And then the minus and the minus would be a plus, so we would have plus. Now, look at this. I'm coming to 1 from the right-hand side. So let's look at this. So that means I would be plugging in numbers like 1.1, 1.01, 1.001, and so on. So as I'm getting closer and closer to 1 from the right, well, the numerator, it's just going to stay at 1. But look at the denominator. If I plug in 1.1, I would get 1 over 0.1. If I plug this one in, I would get 1 over 0.01. Plug this one in, 1 over 0.001, and so on. So you can see what's happening is the denominator's getting smaller and smaller, but the numerator's staying the same. So that means the whole fraction is going to infinity. So this part right here is going to infinity. Well, negative infinity. I'm making this a plus and a plus, so this would be going to infinity. So it's not approaching any number. It's not convergent. So this diverges. Okay, and so what we can say then about this thing here is we can say this diverges. And that would be your answer. And you might be thinking, well, okay, you did that one, but you didn't do that one. Well, if I do one of them and one of them diverges, that's it. You don't have to do the other one. Okay, it's probably going to diverge too, but we don't have to even worry about showing that. All right, so that's the video. All right, I hope you enjoyed it. Sorry about the little technical difficulties there. I'm going to have to look into that and see what's going on. But I think it might be I just have too much stuff in my OneNote, because think of all the videos I have posted. It's a lot. All right, so hope that helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.